Welcome to the All Access Podcast from the experts at Tebis. Each episode, we'll talk about technology topics, trends, or solutions that manufacturers need to know in today's rapidly evolving times. Sit back, enjoy the discussion, and let us know what you think.
Well, welcome to the All Access Podcast. I'm your host, Michael Thiessen. Welcome to everybody that are listening out there. We are all excited to bring you this series of podcasts. There's a ton of information that I'm going to bring to you. It's going to be a little bit different than some of the other podcasts that are out there because we're looking at a lot of different, very interesting topics that potentially are probably going to interest you and make a difference in your life, especially in your business. And this is where we're hoping on elevating your company, elevating your strategies in what you're doing going into the future. So we're excited to bring you this series of podcasts. The podcast, again, is called All Access. And this is our first debut into the podcast world, and we hope that you're going to enjoy this. So what's this topic about? I mean, a lot of you guys that are in the machining world and the manufacturing world have been dealing with machining for, I guess, quite some time, last 20, 30 years at least. Some of you newcomers, welcome to that industry. And I think this particular topic is definitely going to interest you on how the industry is going to be developing over the next 10, 20 years, or maybe even longer, especially if you just started. So what we're going to do is we're going to very briefly look into just the past of where did this area of milling CAD/CAM come from. And I'm not going to dwell too much on the past. And then we're going to look a little bit in the future. And, the machining world is very interesting, very developing, very rapid. I mean, if I'm going to go back 25, 30 years when I started in the industry, and I look back to the software products that I was using back then, I can tell you I do not want to go back to that particular era. These systems that I used were clumsy, they were old-fashioned, they were not definitely the newest thing that was out there. Probably at that time, I was thinking, hey, this was great, dealing with SGI computers and Unix systems and all those kind of things. So those were all things of the past. And we've come a long way to technology that we see today. So in the last 20 years, really, when we look back, machines have improved. When we look at these old clunkers that are still somewhere around in somebody's back room, these machines are dinosaurs and are pretty much extinct when you look at these new machines that are out there with so much new technology embedded in there. So technology has definitely developed in the machining world, in the manufacturing world as a whole. And so when we look now at the next 20 years, these next 20 years are going to be extremely exciting when we're seeing these new machines coming in with robotics and all those kind of things. So it's going to be a lot of fun. So just recently, I was watching a documentary on Back to the Future, and so I was thinking, okay, if we would have all the chance, where would we go to? Would we go back to the past? Would we go back to the 1980s when the industry started with CAD/CAM and all of this? Or would we go into the future to kind of see how is this entire machining world gonna expand? What kind of technology will we be using in the future? And how are we going to be doing manufacturing in the future? I mean, to tell you honestly, I probably would want to go at least 50 years or so into the future just to kind of see what do machines look like. Do we even have people that are going to be doing CAD/CAM operations? Or are they just going to be pressing one button and everything is going to be done? Or are we going to be going into holographic kind of stuff where when we see these science fiction movies playing out in front of us in movies, is it really going to look this way? So I think it's going to be really exciting what the future is going to bring. Now, how about this 3D printing market? This is going to be another important aspect, and I'm super excited. In a few moments, I'm going to introduce you to a gentleman. He has seen the industry firsthand develop. He has gone back even further than I've gone back in history and seeing really how CAD/CAM really started. We will talk to him a little bit closer, getting his perspective and his expertise and what he has seen. So how about these new generations that are coming into play? I mean, we have Generation X, Generation Y, then of course the baby boomers are going to be retiring out of the industry and taking their expertise with them. So how is that all going to look? So what we're going to do over the next 30 minutes, we're going to talk to Gerardo Mueller, who is the Director of Sales, the International Director of Sales from Tebis AG. One of the leading CAD/CAM solutions in the industry. And we're going to talk to him a little bit about the interesting role that CAD/CAM is playing in our machining world and what kind of impact 3D printing and new technology has on as we go forward. So welcome, Gerardo. Welcome to All Access Podcast.
Michael, thank you very much for your introduction. I'm excited to be here. Thank you for having me.
Wonderful. Gerardo, just to let the listeners a little bit know, you have been at Tebis AG now for how long?
30 something years, 33 years. And I was really one of the first employees of Tebis. Back then, it was a small startup company, just 5-6 employees. And I joined in as a sales rep, and I just had graduated from the Technical University in Munich. And one of my majors at the university was the comparison of two CAD/CAM systems. Back then it was Strim 100 from Sisigraph and CATIA V3, and analyze the suitability for the mold and die market. And as you mentioned earlier, history has developed, technology has developed. Back then, in those early days, CAD/CAM software was used to machine clay models, and the intent was to use this technology also for die manufacturing, for mold manufacturing. But if you're early participant of this industry, then you will recall machining in hard materials, steel, cast iron, and so on, was not possible with the technology provided with the software at that time. So duplicating was the technology, and CAD/CAM software was used to either machine clay models or to create duplicating models. So this is how it all started.
So I think it's safe to say that you were clearly pretty much at the birthplace of when CAD/CAM really started and became a popular item in the industry. And you saw really the effects of what it did in the machining world or the manufacturing world. How was it liked by the people back then? And what was it like back then when you started with CAD/CAM?
Well, CAD/CAM at that time was a very, very expensive technology. Sophisticated software was available to be run on mainframe computers. And there was a transition of the software to be used on what they called microvaxes, microsystems at those times, microcomputers, which were still very, very expensive. And when I started working for Tebis, we started, and this I think was a major innovation. The software was running on a personal computer. So back then we're talking computers with a 80-86 processor. It was on the verge to 386 processors, and it was unheard of that you could offer a software, 3D CAD/CAM software, running on such low-end computers. But our customers were also small shops. I mean, they were model makers. Remember, I said software was available to create duplicating models, and these shops, they could not afford a mainframe computer, and suddenly making this CAD/CAM technology available on still expensive but much more affordable personal computers. This was the real breakthrough through the industry, and competitors of that time, which were running only on mainframe computers and microcomputers, had to switch their software, their technology to become available on workstations. You mentioned SGI, Unix, those type of systems, and later on, this technology evolved into the Windows NT, Windows New Technology operating system. So this is how this all started. And when the software finally was capable of machining on multiple surfaces, then we were starting to see a breakthrough. So customers machining molds and dies were becoming interested in this technology.
I mean, definitely the way how the computers have evolved kind of aided the capabilities of CAD/CAM machining and machinery as a whole. If computers would have not made it to the forefront so that everybody of us would have a computer, I also believe that potentially machining or NC machining as well as CAD/CAM would probably not as popular, and we would not be making molds and dies or even aerospace components as we see in today's world. Now, we know each other now for almost close to 20 years now, 19 years now each other. And early on in our relationship at Tebis, I asked you a very important question when I was just hired in. And one of the question that I have, and maybe you don't even remember it, and hope maybe you do still, I asked, okay, where do you see Tebis go? And this is now 20 years ago. Where do you see Tebis go in about 20 years? Where is this software going to be at? And do you remember what your answer was?
Yes, of course I know, Michael, because you raised this question during your interview. This question was, where is this technology going to? And what I answered to you was, people want to be able to design parts, have a physical model of this part, and actually drop that design onto, let's say, icon. And this would automatically trigger the creation of toolpaths and actually automatically run the machine. This is a trend which is still being followed, and we are very close to that goal. Today, there's many parts which you can design and actually just automatically create toolpaths for these parts, and this is a clear trend.
You were spot on. I mean, back then, 20 years ago, that was exactly the question and the answer that you gave. And today, I mean, as we see it, not only I think Tebis is definitely the leader when it comes to that kind of technology, but I think as a whole, the entire industry has gone that way, that they're developing more and more capabilities for potentially automatic type of machining or automatic type of processes. So that was back then. Now we hear, can you imagine where we're going to be in 20 years or 50 years? If you would want to go to the future or the past, where would you go? Would you go in the past and pick up a hammer again and a chisel and do that kind of stuff? Or would you want to go in the future to see how is this all going to play out?
Yeah, of course, we're aiming towards the future. We cannot go back, Michael. So we have no choice.
Oh, man, it definitely is exciting, Gerardo. But, you know, I want to talk to you about another emerging technology. I think it's no longer emerging, really, because it's already here. But 10 years ago, we've gone to shows, and back then there was a show called a Rapid Show. I think it's still going on. And I remember when the first 3D printer came out, and this 3D printing was kind of looked at, it's just a fad. But it really took the industry in a storm. And seeing where this 3D printing is currently at, also in the industry, what it's doing, can it pose as a major threat to the milling industry? What's your thought about it?
Mm-hmm. Well, 3D printing is basically adding layers of material to one another. And there's a differentiation now. In the early days, material was very limited to certain polymers. And nowadays, this technology offers a very large variety of materials, compound materials, soft and hard materials, materials with different characteristics, metals, and 3D printing has become a disruptive technology. So it is here to stay, and it is gaining more and more market share of the manufacturing industry. So this is not going away. And it's the opposite. It is evolving and developing as fast and maybe even faster than the traditional milling or the traditional manufacturing method. So companies in these businesses today or in the past were concentrating on mastering the process, on actually obtaining usable parts, reducing scrap, these type of problems. Nowadays, 3D printing is about becoming industrial production. And the questions to be answered here are, how are we controlling these processes so that we can produce parts on demand? So heavy players in this business, they look into setting up manufacturing cells which are linked to each other, where the processes of 3D printing is controlled, and whereas customers can request, well, I need of this certain part, I need a batch of 10, or I need a batch of 10,000. This is the driving force here. At the same time, we're experiencing a mix of manufacturing technologies and methods, not only, let's say, in the traditional area, milling and drilling, or conventional machining and 5-axis machining, but also a mix in machines that are able to 3D print, but actually also to subtract, to machine and remove material from the 3D printed object. So each technology has its limitations, but also a lot of advantages. And companies, some companies are looking into combining the advantages of additive manufacturing and subtractive manufacturing into one single machine. So software should be able, or you will be able to see software that is capable of servicing both technologies. No?
So, I mean, essentially, what I'm hearing from you is, if we tie both of those industries together, the additive and the subtractive, and essentially create one entire industry from the manufacturing side, the subtractive solutions, the machining portions of it, are not going to be as hard hit. I mean, currently what we're seeing is, of course, we're seeing the additive market come in, if that's metal printing, if that's plastic printing, if that's for prototyping, or if that's even for production nowadays for smaller parts, that we're seeing these things kind of emerge. Of course, those kind of things are taking a little bit of that market on the subtractive away right now, because they're no longer going to be machining those little parts. But if you tie those two together, now you have one cohesive, fast, accurate, and high quality type of parts that can be produced. I mean, if I'm hearing from you correctly, putting the subtractive and additive pretty much together into one machine that can handle both of it.
Yeah, putting everything into one single machine, I think this is maybe exaggerated. I'm sure there's going to be available machines that can do both. But as any other company today that is in manufacturing, they still utilize machines that are specialized on particular tasks. So you will have large machines, small machines, machines for laser cutting, for wire erosion. You will have die sinkers. You will have milling machines, and you will also have additive manufacturing machines. So I think the customer base in manufacturing, they will clearly adopt this technology and use as they need in order to deliver to their customers the products that are actually requested. And additive manufacturing has a lot of advantages when it comes to design of intricate parts, complex part, weight reduction, those type of things, while traditional machining is also evolving. And I mean, additive manufacturing is a buzzword, so you think that technology is residing, or new technology is residing in this area. But if I may shift again to traditional machining, also here we are seeing huge changes in the technology. For instance, machines become ever more precise, ever faster, the ability to run not only 3-axis, but actually 4-axis or 5-axis or even more axis. This becomes ever more evident. The tooling industry is evolving extremely fast. Just to mention barrel cutters or circle segment cutters, this technology is not as visible, does not drive as much attention in the media as additive manufacturing, but this technology is certainly as important and as an important game changer in the current manufacturing industry as the additive manufacturing is.
I mean, you're 100% correct. In the machining side, there is a lot of new technology that's coming up. If I look at machines currently, 5-axis machines that are out there that have now robots inside machines to do some of the tasks. If that's just tasks for either setup or for tooling, grabbing of tooling and stuff like that, I mean, those machines have really been enhanced. And at times even it has made it more difficult, these machines, to run either conventionally or non-conventionally. Post processors have really become intricate type of machinery to translate the information from the computer to the machines so that these particular items can come across correctly. So if I look at mill turns, for example, mill turns really have come up to the forefront in the last 10 years, really. They have been almost kind of like silent when it comes to that kind of things. And so it's kind of interesting of how that particular technology is emerging there.
Yes, and I mean, this you mentioned keyword mill turns. This is correct. This is a new type of machine, very complex machine, because the machine is extremely well suited to produce finished parts in, let's say, one setup, and this means these machines are best suited to be run on a 24/7 environment, at least to aim to run them on a 24/7 environment, because as you know, Michael, 24/7 automation of these type of machines is key to make them affordable. And we have the problem today that we lack skilled workforce, and the entire manufacturing process needs to be condensed on a single machine. So this is another reason why additive manufacturing is increasing so much, but also on the conventional machining methods, these machines become more complex, and you just need to be able to control these processes. So automation is the key word.
I mean, I think you put your finger directly into the wound of what is really going on in our industry. I mean, when we drive around in our vehicles and seeing how many for hire signs are out there, and how many in our industry, I just recently talked about with some mold makers on the capability and the ability to find people that can do this kind of job. It is really mind-boggling that we can get the jobs still today done. And then on top of it, if you throw in technology that are a little bit more complex, it really puts a bind into it. So, I mean, you mentioned already one answer on how we can combat potentially the labor shortage, and that's through automation. I mean, automating is, from what I see, the latest buzzword. Everybody's now looking into it because obviously they can't find people. They can't find experienced people. And I mean, all of our baby boomers, our gray-haired wizards that are currently still in these mold and die shops and aerospace industries with 30, 40 years of experience, getting close to retire and enjoying their golfing life and all that kind of stuff. How are we going to bring this experience, and how can we keep this experience, at least with these companies?
Yes, that's the question, and the answer is, if you are pursuing automation, then you can only automate things that you have tried out up front. If you are in control of a process, if you're in control of how you manufacture in a supervised environment, then you can start thinking about automating things. So, in other words, you need to be able to try out things up front. You need to be able to simulate things. And coming back to the computers, then you need software for it. And software needs to replicate your manufacturing environment into a digital environment. And to do this, you need to look into your process. You need to know which equipment you're using and which equipment you're intending to automate. So you need to have virtual models of your machine tools that behave in the same way as your physical machines. You need to have virtual models of your tooling that is identical to the real tooling you have available. You need to set up parts. You need to clamp parts. So we're also talking about virtualizing the setup and clamping environments. Then you need to also store the know-how on how to use this equipment. So here we're talking about using or filing this knowledge into templates so that all these repetitive tasks of setting up the part, starting to run, let's say, roughing process, then continue into a re-roughing and semi-finishing and finishing process. These different steps, which always vary depending on materials used, which will vary depending on machines used. You have high torque machines, you have high speed machines, you have all type of different machines. You even have knowledge about how these machines behave. So you know, to achieve a certain accuracy, you can only use a certain machine up to a certain point. Beyond a certain accuracy expectation, this machine will not render repetitive, reliable results. So all this knowledge needs to be filed somewhere, and you need to have a container where you put in all this knowledge. And software today is evolving in such way so that this knowledge is stored and made available not only within your periphery and your company, but maybe across locations. Many customers have a manufacturing site in a plant A in one location and plant B and C in other locations. And obviously, proven processes need to be modified and adjusted to the circumstances which are available at a different plant. And then you can aim for automated manufacturing. And if you have that, then the individual knowledge which is filed and which is which has accrued over time in the heads of each individual becomes available for the entire shop or for the entire company. And this is how things will evolve, and we will need ever more people, and we will need ever more smart people to transform traditional manufacturing into digital manufacturing.
Yeah, I'm just amazed, Gerardo. You talked about all these capturing of knowledge and putting them in containers. I mean, essentially, what you're doing for the simple man is just simply creating a cookbook. I mean, a cookbook for with various ingredients, with various machines, parameters, strategies, cutters, all this kind of stuff. You put this all into a recipe, and it's going to be a recipe for success over and over and over again. And because you can put these strategies now in motion, your quality is going to improve because you're standardized. You can predict what the quality is going to be. You can tell with certainty how good this part come out. I mean, there has been so many times that even I have gone through in multiple plans, and now you can see definitively who has programmed certain parts because of strategies that have been used. And if you automate and you do this, then of course you can predict a lot better. Let me switch to another very important topic there. You talked earlier about the loss of people or the labor shortage that we've got going on. I mean, from my perspective, what we're doing here, at least in the U.S., and you're sitting currently in beautiful Germany over there, and when I look at how labor or how skilled tradesmen are being brought up, at least in Germany, and compare that to here to the U.S., there's a big difference. You have in Germany trade schools, kids come out of high school early on, and they can make a decision to go into these trades and learn these trades and move up. Over here in the U.S., we don't have this. Certain companies, I just was recently in a local mold shop here. He believes very heavily on young generation. He has an apprenticeship program in his company and really starts these young high schoolers up on the path of tradesmanship. When I look at Mike Rowe, for example, all of you guys know him from the Dirty Jobs guy. His foundation is really looking at increasing trade again, increasing the tradesmen, and learning what it means to build something with your hands, because there is a certain satisfaction that comes out of something when you build something. Now, when I compare those two, those models are completely different. I believe in Germany, it's not quite as bad as maybe as what we have here, because we have youngsters that rather want to go to college and have a nice cushy job and a management job and all of this, and we don't have enough people coming into the machine floors.
Yeah, Michael, you are addressing a problem which I think can be seen throughout the industrialized world, the shortage of skilled labor workforce. And no matter where you go, if it's in the US, I think in Europe, in Germany, and also in Asia, we are facing the same problem everywhere. And in Germany, what you mentioned about these trade schools, vocational schools, yes, it's correct. Our youth has a choice, either picking trade, a guild training, and there is a saying where it says, well, trade stands on golden ground, meaning that you can later on earn a lot of money if you know what you're doing, and you have this skilled know-how available. But at the same time, technology is evolving so much, and you have disruptive technologies showing up everywhere. I mean, computers, when they showed up, and CAD/CAM and our technology showed up back then, trade schools were showing youngsters how to produce a duplicating model and how to create models. This technology has completely disappeared. So also this is constantly evolving, and we also need the people that are attending higher education, because automation and linking technology is always connected to software, computers. I don't want to bring up now this buzzword cloud computing, but all this is also disruptive, and this is again changing then an entire technology. So to summarize, no matter what you do, you need to invest into training. You cannot afford buying a machine, and you cannot afford not training your workforce on how to use your equipment. If this is your strategy, you're dead wrong.
You're 100% correct. Training and getting people trained early on and how to utilize the products correctly, it's vital for success. I mean, I'm not going to put a 16-year-old kid into a Ferrari and giving him the key to this brand new toy and tell him to go off and have fun without giving him training courses first of how to drive this thing, because in the first corner, that car will end up in the ditch. I mean, training is an important subject that potentially this is something that we need to dive a little bit further in another future podcast. But I mean, really, the machining area, the industry that we are in, is really an exciting industry. Seeing all this technology that comes up, and I guarantee you cannot divulge all the secrets that are going on in the deepest, darkest labs of Tebis, because you're developing all these products in-house. You cannot divulge if you guys are working on VR technology, or if AI is going to be a major item in there, or even cloud computing, or any of those things that are coming up. Give me your opinion. What is the future going to look like? Can you envision that CAD/CAM technology is going to be going towards virtual reality, or even AI, artificial intelligence?
Yes, absolutely. And I mean, you already have the blueprint up front, because the actual part that needs to be machined is already available in its finished state as a digital model. So today, or there's technology being developed that allows you to compare this digital model against a machined component sitting either on the machine or sitting on the shop floor. And you use this technology, augmented reality technology, to compare if the finished component, the machine component, actually resembles and matches the designed intent of the digital model. So this is becoming a reality. When you say simulation, every new machine available on the market, any customer that buys a new machine, he will demand a digital model, a digital twin of this machine, in order to not only control the process, but actually also to ensure and save his investment, because without simulation, no machine will run in future. And this is a trend becoming ever more evident as complexity of the machines.
Well, we've even seen this, Gerardo, with the pandemic. What we saw throughout the entire last year, we saw a lot more questions about automating, about programming from home. And essentially, you could be programming from Germany for a machine that's sitting over here in the US if you have all of these virtual entities already inside your system. If that's the clamping devices, if that's the machine, the tooling, all of those things, you can do this today. The VR, yes, potentially this could be a very interesting item. AI, we're seeing more and more of this AI come into these computers and these softwares. I could also see this. So I think the CAD/CAM technology now is on a verge of really integrating a lot of these intelligence and a lot of these entities into it. However, companies need to realize they need to invest now more than ever into standardizing their equipment, automating their processes, and getting really their thoughts around this. Because you know what? If you don't do it now and you wait another 10 years, you probably are going to be the 1%ers that end up falling behind.
Yes.
You probably are seeing that too.
Yes, it's a race, Michael. It's a race, and you're absolutely right. There's a few customers today that are able to conduct remote programming investment of their machine tools, no matter where these machines are sitting, because they have standardized the processes. They know exactly how to produce these parts, and they have adapted their templates, their manufacturing templates, to the locally available tooling, or if this tooling was outdated and is no longer was not compatible, then they furnished these locations with modern machines and used the tooling they know how to control on these machines. So this is becoming reality. It's another method to combat this lack of skilled workforce, because you condense and you compress this knowledge into your systems and use it as you need with the existing equipment. And when you add new equipment, you modify and adjust these processes to the new capabilities.
Mm-hmm. So the advice that you could give to a youngster that's now just looking into what kind of job is he or she going to do, and what advice would you give in order to sway that person to get into the machining industry or the CAD/CAM industry? Is there a future for them?
Yes, absolutely. The future is even more visible than ever, because we are consuming more and more consumables, if you like. I mean, in the past, we were buying cars to be used, let's say, for 10 years, 15 years. Now we're switching cars every 3 years as soon as the lease expires. So the same happens with your computers, with your TV at home. Any type of gadget, anything you buy is the consumable, and these consumables become more and more complex, different materials. You need more and more manufacturing capabilities, and there's a tremendous opportunity to earn money. And as we are seeing, also the world is changing. People are no longer happy with the idea of producing parts in one part of the world and shipping them across the globe around just to have them available on their doorsteps. They want to produce them locally. And I think this is a trend not only in the food industry. People are asking, well, where's the food being produced? Where's it coming from? Do I really need to buy something that was raised halfway across the globe? So the same will happen with other things. And as we notice now during the pandemic, these delivery chains are actually fragile and can be disrupted easily. So this is part of the current inflation, the current situation. We see that we are now a shortage of many goods. This will be countered by producing locally.
Well, I can tell you this, and also to all the listeners out there, I got an update yesterday on the industry of molds and dies in the industry, and I was amazed of the trajectory of the industry, of where we're going to go here in the next 2-3 years. And it's really picking up. The industry is healthy. The mold making industry, the die making industry is extremely healthy. They're coming back with a vengeance. And we will see definitely an increase on new machinery that's going to be provided to companies worldwide. And we're seeing a lot more technology that's coming up. So it's to all these youngsters that are listening to this particular podcast here, there definitely is a future. The industry is healthy. There's a lot of money that can be made. We see a lot of startup companies too. I mean, if we look at the battery electric vehicles, all of those are coming out of the woodworks, and there is more and more tooling going to be coming up for those companies there as well. So the industry is extremely healthy. Gerardo, I know we could be going on forever talking about these kind of things. So let me track back to the question that I asked you 20 years ago. In 20 years, I know you're going to be on the golf course probably kicking balls around, but in 20 years, what do you see the industry is going to be at? I mean, you were pretty much spot on when you told me vision is of Tebis back then, or the industry back then. 20 years from now, your prediction, where will we be?
Yeah, my guess is, as we outlined, for additive manufacturing, also for machining, we will have a on-demand production, And the future CAD designs will be manufacturing ready, so that you can derive from the CAD design, you can derive all the intermediate stages in the manufacturing process. So you will have the shapes that are necessary for ideal roughing operations. You will have the shapes available for ideal finishing operations. These are all created by software, and you will really have a push-button creation of parts. I don't want to say push-button creation of toolpaths, because the toolpath itself, I think, will become invisible. It is just the ability to press a button and say, produce this part, this design. So this is in my opinion, where we will see things in 10, 15 years.
So in 20 years, we will have the Staples Easy button in front of us, and we're going to press the Staples button and out comes a part, essentially. But in order to do this, what we need to do as manufacturers of mold makers and die makers, as well as in aerospace, we need to prepare in order to be there in 20 years. We need to automate. We need to find solutions, CAD/CAM solutions that can really elevate that particular idea in order to hit exactly what is coming up. Industry 4.0 is another buzzword that we're going to be diving into a little bit more later on, but that's also an item that can push us a little bit further. So we'll leave that as this. Definitely an interesting industry to be in. Lots of future that's going to be coming up with new technologies. I know you're going to be seeing it before even I do, what this technology is going to look like, because you are at the heart and the center of all the development that's happening. Gerardo, I thank you for being here at this podcast, giving us your insight, your knowledge, your expertise. Any last comments from your side?
Yeah, Michael, thank you very much. It was a pleasure talking to you, and thanks for having me. And I hope in 20 years I will not be kicking golf balls, but actually putting golf balls. So.
Wonderful.
Thank you.
Thank you, Gerardo, for being part and giving us your expertise. We're looking forward of having you on the future. Mm-hmm. Thank you.
Thank you, Michael.
All right, for all of you listeners that are out there, hopefully you guys have enjoyed this podcast. One last comment from my side: this industry that we are involved in the machining industry, the CAD/CAM industry, is really, truly an exciting item, an exciting industry to be in. If you're right now getting out of high school or you're in college and you're wondering what that should be, I ask you, look into it. If you're a school teacher or a school director or anything like that, get back shop classes in your high schools. Get that going, because we need these people. We need experts that really know how to operate machining technology. Get those courses back in. Get the trade schools back into action, so we can really further individuals from the inside, so we can cope with this labor shortage. And I thank Mike Rowe for doing just so much good in the industry and in the trade schools, and I salute him. So from my side, I say thank you. Thank you for listening to the All Access podcast, and we'll see you next time. Thank you.
Thank you for joining this episode of All Access. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about manufacturing technology solutions and Tebis's capabilities, visit our website at Tebis. That's TEBIS.com.